Hello, everyone. This is Mr. Santoro. Happy New Year. I know it's been a little while since we've had a screencast, but welcome to one of the last screencasts in our unit of calculus that we'll be doing. This is the screencast on integration. You all have the note sheet in front of you. So we're going to talk about writing the antiderivative or the integral of 2x, and we're going to write it with this funny little sign here. And we're going to say integral of 2x dx, right? The symbol, that little symbol, it's called an integral. And this is an indefinite integral because there are no numbers here for limits, upper and lower limits. And you'll see that a little later on. This integral sign will have numbers above and below, and we'll see how to handle those. The process of doing this is the same as finding the antiderivative that we've been doing, okay? So if we were to take the antiderivative of 2x, it would be x squared, and then plus c. Don't forget the plus c. So let's take a look at these indefinite integrals that we have here. So what we want to do is find the antiderivative or the integral, or we want to integrate, okay, we can use that term as well, of 3x. So we have 3x squared over 2 plus c, right, because we're going to take the exponent of 1, add 1 to make it exponent of 2, then divide by 2. And as you can see, 3 halves x squared plus 6. Let's take a look at number 2. We want to integrate x. So again, the exponent is 1. You add 1 and you have 2. So you have x squared over 2 plus c. Got to remember the plus c. And then clean that up, and it's 1 half x squared plus c. This is pretty much exactly what we've been doing in class. If we look at number 3, what's the antiderivative of 4x squared? Well, you're going to take 4x cubed, divide by 3, plus c, and you wind up with 4/3 x cubed plus c. And if we now take a look at the fourth one, this one's a little longer. The antiderivative of 4x to the fifth plus 7x squared minus 4x. So, take all the exponents, add 1, divide by the new exponent, just like we've been doing in class. Don't forget the plus thing. So we clean that up, and the antiderivative, or the integral, of 4x to the fifth plus 7x squared minus 4x is 2/3 x to the sixth plus 7/3 x cubed minus 2x squared plus c. So that's an indefinite integral because we're not looking for an upper and lower limit. So as we go to the next page, I had a pop up here, and I don't know why Google Drive's not responding. Okay, all right, I don't want to check for solution because I'm in the middle of something. All right, so let's take a look at this. A definite integral has an upper and a lower limit. Okay, and we'll see how we're going to evaluate that. So we evaluate the definite integrals using something called the fundamental theorem of calculus, which is right here. And it's this, and it's, wow, look at all that. That's great. So let's take a look and see what it really means. How do we actually do it? What's the process to evaluate the definite integral? Let's take a look at this first one. 6x minus 5. So we want to integrate that. And we want to look at upper and lower limit, upper limit of 2, lower limit of 1. So the first thing we have to do is we go from 6x minus 5, 6x squared over 2 minus 5x plus c, and we wind up with, okay, clean it up, 3x squared minus 5, oh, that should be a squared there, it was a typo. Okay, I'll fix that later. It should be 3x squared minus 5x plus c. So the upper limit is 2. So we're going to evaluate this 3x squared minus 5x plus c, and we're going to put a 2 in for x. minus, so it's the upper limit minus the lower limit, and we're going to evaluate the same function, only putting a 1 in there first. Now look what happens with the c. 2 squared is 4 times 3 is 12, minus 10 plus c, minus, keep everything in parentheses at this stage. 1 squared is 1, 3 times 1 is 3, minus 5 plus c. When we can combine like terms here, 12 minus 10 is 2, plus c, minus, that minus sign comes from there. Now we're going to look at what's in the parentheses. 3 minus 5 is negative 2. Okay. That should be a plus c, but then when we distribute the negative, it becomes negative c. So the c's cancel out. The c's will always cancel out. And you'll see that as we do more problems, the c's always cancel out, and we have left 2 plus 2. So we've evaluated this definite integral for an upper limit of 2 and a lower limit of 1, and the evaluation of that integral is 4. So we'll be seeing what that means within a couple of days. But we need to get the process down on how to evaluate an integral. Okay. So let's take a look at another. So we're going to look at this integral. 4x squared minus 3, upper limit of 2, lower limit of 1. So we're going to do what we've been doing. Antiderivative. 4x squared becomes 4x cubed, divide by 3, minus 3x plus 3. When we simplify it, we have 4/3 x cubed minus 3x plus 6. So I hope everybody's all caught up to that. This is exactly what we started doing before Christmas vacation, and that's what we've been doing the last couple of days. So again, we're going to take this function, 4/3 x cubed minus 3x plus 6, and the upper limit is 2, so we put the 2 into the x, minus the lower limit here is 1, so we're going to put the 1 into the x. So when we evaluate this, 2 cubed is 8, times 4 is 32 over 3, that's where that came from. Minus 6 plus c, minus 1 cubed is 1, 1 times 4/3 is 4/3, minus 3 plus 6. (32 over 3 minus 6), do that in your calculator, is 14 over 3. Convert back to a fraction. The fraction deal is very big with the integrals, and you'll see as we move along, you can put in your calculator 32 over 3, put in parentheses, subtract 6, convert back to a fraction. And you'll get 14 over 3 plus c minus 4/3 minus 3. You put that in your calculator and you get negative 5/3. So we have minus negative 5/3, and then the plus c becomes a minus c. The c's will cancel. 14 over 3 minus negative 5 over 3. So that's 14 over 3 plus 5 over 3 is 19 over 3. We've evaluated that integral. Upper limit 2, lower limit 1. Let's go back and take a look at what we've done. We're going to take the antiderivative as we've been doing the last several days. That's this. We simplify it, and then we have our function right here. We're going to evaluate that for an upper limit of 2, lower limit of 1. So we take that function and you put a 2 in for x, minus, same function, put a 1 in for x. So let's go upper and lower limits. Okay? Make sure you maintain the parentheses. You can use your calculator to evaluate within the parentheses. At this point right here, you could really cancel those c's out, because we know plus c minus c is going to net to 0. So at this stage right here, you can just can't put a line through the C's, cancel them out, and you're done. Okay. Again, use the calculator. Handle the fractions, minus an integer, fraction plus an integer. Handle all that with the calculator. Okay. What I have on the next page are some practice questions. I want you to do those. The first 4 are nothing more than antiderivative questions like we've been doing. Okay? Just like we had on the quiz. The last 2 are evaluating the integral for the upper and lower limits that I have here. I want you to start working through that. Use the example 1 and 2 that we just completed as a model. At least you should be able to set up, take the antiderivative. Even though the C's cancel out, you still have to put the C in there. Mathematically, you need to continue carry the C along until the point at which I spoke about before that you can cancel them out, but you need to put the plus C in there mathematically. Okay? And you should be able to do the substitution. So I want you to spend the time and go over these. Try them. Use what we did before. Go back over your notes. Replay the screencast if you need to. But I really want you to put a good effort into trying, especially 5 and 6. 1 through 4, we've been doing that for several days. Everybody should be able to do that with great success. So thank you for tuning into the screencast, and I will see everyone in class.